Hello everyone, welcome to my YouTube channel. So anyone who is interested to learn ETAPS from basic to advanced level with a company live projects, so directly you can contact me. This is my email ID, that is mdtahirrahman468@gmail.com, or you can contact me directly. My mobile number is 987 33 48 467. Okay, so you will get all idea about that from, because already I take lectures from the online and all. Okay, so those who are interested to learn ETAPS from the basic to advanced level with different life of projects up to the G+40 G+50 and all, you can directly contact me. Okay, so today we are going to discuss about some raft foundation. Okay, because yesterday we discussed about isolated footing and we discussed about that combined footing, how we provide the reinforcement in that. Okay, so today we are going to discuss about raft foundations. Okay, so already you know that what is raft foundations. Raft foundation, in the case of raft foundation, it is like, see, suppose this is your raft foundation. Okay, so raft foundation is also called what? So raft foundation is also called mat foundations. Raft foundation is also called mat foundations. So in the case of raft foundation, what is the difference between raft foundations and isolated footing? So the basic difference in that, in the case of isolated footing, already I have been discussed in my previous lecture, that you can look that there. So in the case of isolated footing, we generally provide the steel reinforcement in one layer only. Okay, like this only. So this is the main bar, this is the distribution bar. But in the case of raft footing, we generally provide the reinforcement in two layer, like combined footing. Okay, so top layer also and bottom layer also. So in top layer also x and y axis steel we can provide, and in bottom also we can provide x and y. Okay, so we will see here what is this raft foundation and all. So here you can see that this is the bar directions and all. Okay, this is the reinforcement. Here you can see this is the main thing of the sections. Okay, this is the plan, but you can see in the sections. So in sections you can see that this is the raft foundations. In raft foundation we generally provide the two column here, and in top you can see that this is the top. Okay, so in top that is x axis and y axis, this is the top layer, this is the top layer. So here we can provide the, see, this is the main bar and this is the distributions bar already here. Okay, in bottom also we generally provide same x axis and y axis, bottom distributions bar, and this is the main bar. See, this is the bottom main bar and this is the bottom distributions bar. So in the case of raft foundation, we generally provide the reinforcement in two layer, top layer and bottom layer. But here you can see that what is this is the chair. Okay, because we generally provide the chair to keep the distance between top layer and bottom layer. So in between we generally provide, see, this is the top layer and this is the bottom layer. So in between we generally provide the chair shape like this. Okay, so the minimum dia of the chair should provide is 12 mm. In the case of raft foundations, if you are going to provide the chair, so minimum diameter of the chair you have to provide how much? That is 12 mm. And what is the spacing between one chair to two chair? The thing is that, see, here this is the one chair, and again we are going to provide one chair, again we are going to provide one chair. So the distance between this is how much? 30 into diameter of the chair rebar, means suppose 12 mm we provide, so 360 mm we can provide we can keep the spacing between two chair is 360 mm. So always you have to remember that the distance between two chair is 360 mm, means 3 into diameter of the chair rebar. Always this type of question generally asked in interview. Okay, what is chair and what is the minimum, what is the spacing we generally provide between two chair. Okay, so you have to remember the formula. Okay, that is 30 into diameter of the chair rebar. So they will ask that what are the minimum diameter of the rebar we can provide according to SP34. So you can say that according to SP34 code we can generally provide the chair rebar dia is 12 mm. So 30 into diameter of the chair rebar. Okay, And other thing is that you can say that, see here this is the side reinforcement, okay, because if D is greater than 750, we have to provide the side reinforcement. What is side reinforcement? Already I have told in my previous lectures, in my one of the video what I have been uploaded. You can see there, suppose the depth of the beam is more than 750 mm. Suppose this is your beam, and if the depth of the beam is more than 750 mm beam of slab whatsoever, so in this case you have to provide the side reinforcement. So side reinforcement, suppose this is your beam and this is 750, so in this case suppose 800, so in this case what you have to do, you have to provide the side reinforcement like this, okay. The distance between two side reinforcement should not be more than 300 mm, always you have to keep in mind, okay. So here see, in the case of raft foundation also, if suppose that you are going to provide the thickness of the raft foundation is greater than 750 mm, because mostly what we do is that when we are going to construct in very large type of structure and all, so sometimes we generally provide the thickness of the raft foundation is more than 2 meter and 3 meter like that, okay. So means already it is more than 750 mm, so in that case you have to provide the side reinforcement. So if D is greater than 750 mm, then you have to provide the side reinforcement. And in the case of side reinforcement, you have to always remember that the spacing between two side reinforcement should not be greater than 300 mm, okay. So this is the main condition of the raft foundation, okay. I hope you understand. If you have any confusion, just you can DM me directly, or you can follow the code, because already I mentioned here for code also with clause. See, this is 26.5.1.3 IS 456 2000. According to IS 456 2000, it says that if the depth of the beam or depth of the slab and all is greater than 750 mm, then you have to be provided, because if you will not provide, then what will happen? Suppose if you are not going to provide the side reinforcement, the thickness of the slab is more than 750 mm, or thickness of the beam is more than 750 mm, and if suppose you are not going to provide the side reinforcement, what will happen? Then it will fail in shear, okay. So it is very important to provide the side reinforcement for all, okay. So I hope you got is that what are the terms and conditions for the raft foundations, and what are shear. And next we will go for the pile reinforcement detail. Already know that what is pile, because there are different types of foundations, like isolated footing, combined footing, raft and pile and all, okay. So suppose the say bearing capacity of the soil is very weak, suppose suppose 50 kilonewton per meter square. I'm just giving one example, okay, where I am working. So one client, actually I received one projects for the designing, okay, my company. So I started for the design. So initially client said that we don't a pile and all, okay, directly you have to go for the raft or isolated or combined, because that is the terms and condition by the client, okay. They said that, okay, I am, it is not affordable for me to go for the pile and all, okay. Anyhow you have to go for the raft foundation or isolated footing or combined footing, okay. So what I did, that I said that, okay, no issue that. So I started for the design and all. When I have been completed the things and all, and I have been submitted, what happened is that again they called me, okay, and they said that, sir, actually kindly provide the pile foundation and all, because near about my building they have been provided the pile foundation and all. Because what happened is that they said that they don't want pile foundation, okay. So in that case we have provided the raft foundation. The thickness of the raft foundation is how much, you know that it's going more than means like 10 feet 11 feet like that, okay. So it is possible like a room height. So I said that, okay, no issue, that I will go for that, no issue. But again they requested me that, sir, please redesign for that, we want pile foundation all. So again we because the safe bearing capacity of that site is 25 only kilonewton per meter square, less than that, okay. I don't remember exactly, but it is very less. The soil is very weak, like clay and all. So anyhow we have to go for the pile foundation, okay. So suppose if a client says that, just try to understand. I many times I try to understand that when they came in front of me, I just try to understand that what is the need to provide the pile foundation, in which condition we generally provide the pile foundation. But they are saying that no sir, actually we don't want pile foundation, we want wrap foundation and all. Please do. I'm just saying let us discuss that. But when he started for that, many times they are going to fail in punching shear and all. So we are going to increase the thickness like that. So thickness is very much okay. So in that case I said that. So again they called me and they said that no sir, okay, it's better you go for the pile foundation. So when the I'm just trying to why I said this thing is because why we provide the pile foundation, because pile foundations generally provided if the shape bearing capacity of the soil is very less. So in that case we have to go for the pile foundations. Or suppose there is a movable structure, like suppose you are going to construct any bridges and all, they are metro. So you said you have already you watched that in metro there we generally provided the pier pile foundation and all, because there is a movable structures, okay, that is a dynamic loading. So in that case we have to provide the pile foundation. So let us discuss what is pile foundations. So according to SP34, this is also the code, and IS 456 2000. See, we'll discuss about this, a typical pile cross sections. So what is this? This is generally the concrete pile, okay, and there we generally provide the inner ring. This is the inner ring of a rebar. And what is this? This is the longitudinal reinforcement. This is the longitudinal reinforcement, okay, and this is the outer ring, okay. So in that case what happen is that this is the concrete pile, okay, and here this is the inner ring. You can see that this is the inner ring. So we generally provide the inner ring like this, and then this is the longitudinal reinforcement. We generally provide longitudinal reinforcement. So like that we can provide the longitudinal reinforcement. And again we generally provided the outer ring. So suppose this is inner ring and this is outer ring. So like that this is the typical section of the cross section. So in pile there are, first one is that this is the concrete pile, that is first one is concrete pile, second one is inner ring, and third one is outer ring, and fourth one is that is longitudinal reinforcement bar, okay. So this is the four element we generally provide in typical cross section when we are going to construct for the pile, okay. So inner ring, outer ring, pile and longitudinal reinforcement. So now we'll see the this thing, okay, typical pile elevation. So in this case you can see that this is the pile, okay, this is the pile and it is like shoe type, okay. Why we generally provide this cast iron or cast steel shoe? Because it generally means you can say that this is the end bearing pile, because they are when soil investigation report received from the geotechnical department, so they generally provide that which type of pile you have to go for. Either you have to go for the end bearing pile or you have to go for the friction pile and all. They will say that because they will know that what type of soil is there, because due to that they are going to investigate of the soil investigations, and accordingly they will know that because we don't know that we are responsible for the design and all, but soil investigations and all soil report is generally prepared by the geotechnical engineer, and then after they hand over to structural engineer. So they will know that on site which type of soil is there. Either according to that they will decide that you go for the end bearing pile, or you go for the friction pile, okay. Which type of pile you have to go, you can go for, like, okay. So here we can see that this is the shape of the cast iron or cast steel shoe. And this is the minimum. In the case of pile, the minimum longitudinal reinforcement is how much? 0.4%. This is the longitudinal reinforcement we generally provide. So minimum longitudinal reinforcement in the case of pile, how much? That is 0.4%. You have to remember. Okay. And link we generally provided how much? That is 6 mm, but now we go for the 8 mm also. Okay, but minimum spiral diameter of the links, how much? That should be 6 mm minimum, but nowadays we generally provided 8 mm also. And spacing of the links should not be less than how much? 150 mm, and should not be greater than 300 mm. This thing also you have to remember. Okay, this is very important. You can see here. So this is very important here, this part. Links or spiral dia is 6 mm and spacing should not be less than 150 mm and should not be greater than 300 mm. It is very important. And in the case of cover, we generally provide the 50 mm cover for the pile. Okay, because this is the concrete and this is the steel. So in between you can see that this gap is cover. Okay, so in the case of pile, we generally provided the cover is how much? That is 50 mm we can provide. And now we'll see that what code says according to SP 34 clause number 6.9.2. Okay, so a minimum number of 4 12 mm diameter bars shall be provided. Suppose you are going to construct any pile, so how much minimum diameter of the bar we can provide in the case of pile? So minimum you have to provide 4 number of bar with 12 mm diameter. You cannot provide 10 mm diameter of the bar in pile. Always remember, minimum diameter of the bar you have to provide 12 mm in the case of pile. First one. Okay, second one, for pile of length exceeding 5 meter. Suppose this is pile, you can see here. I'm just trying to think very elaborate, so you cop up the things in very easy way. See here, this is the whole length of the pile. Okay, so for pile of length exceeding 5 meter, suppose that this length is more than 5 meter length of the pile, and diameter of the pile is more than how much? That is 375 mm diameter. So a minimum number of 6 12 mm bars shall be provided. First one, what says that in the case of first case, it is saying that the minimum number of pile we can provide, minimum number of bar we can provide in the case of pile 4 bar of 12 mm diameter. But if the length of pile is exceeding, if length of the pile is exceeding 5 meter, then how much you have to provide? Then in this case, minimum how much bar you can provide? So minimum 6 bars you can provide with minimum 12 mm diameter of the bar. Okay, so suppose this is your pile, so minimum how much? So minimum 6 bar, 3 4 5 6. Diameter of the bar is how much? So it should be greater than 375 mm. Okay, and length of the pile is how much? It should be if greater than 5 meter, then we can provide the minimum 6 bars. Understand? Now we come for the third cases. What third case says? Let us see. So in third case, it is saying that for piles exceeding 400 mm diameter, a minimum number of 6 12 mm bars shall be provided. So suppose a pile whose diameter is exceeding how much? So more than 400 mm. Suppose that 450 mm. So minimum how much minimum number of 6? Same, 6 diameter of the rebar we can provide of minimum 12 mm. Maximum depend upon the design load condition and all, but minimum we can have to provide that 12 mm. Now we'll see here, the circular stirrups of pile of length exceeding 5 meter and diameter exceeding 375 mm shall be a minimum 8 mm diameter bars. So nowadays what says that in practical, if you see that, so nowadays we generally provide the minimum diameter of the circular ring is how much. Suppose the length of the pile is less than 5 meter also, so we can go for the how much, so that is we can go generally we can go for the minimum 8 mm diameter of the links. Okay, so this you don't need to follow this one, okay, because nowadays suppose that the length of the pile is less than 5 meter also, so we are following these cases 8 mm, okay, because now we are not going to provide 6 mm links and all. So what we have seen here, so first one we seen that the minimum diameter of the bar you have to provide 12 mm with 4 diameter of the bar, okay, in normal cases. If the length of the pile is more than 5 meter, if more than 5 meter, though in this case minimum 12 mm plus 6 diameter of the bar you have to provide anyhow. If diameter is exceeding 375 mm, in this case you can provide. And third one, if diameter is getting more than 400 mm diameter, also you can provide the same 12 mm diameter of the bar with 6 mm diameter. So 4 mm 12 mm diameter of the bar with 6 number of bar, okay. And minimum longitudinal reinforcement how much, so that is you have to follow 0.4% minimum. Maximum depend upon the design and all, okay. And the spiral, suppose we are going to provide the spiraling, so the spacing should not be less than 150 mm and should not be greater than 300 mm, okay. So this thing in the case of pile, see this is end bearing pile. Now we see that what are the pile arrangements according to SP 34. This is very important. So let us see that what pile arrangement. So suppose you are going to provide 2 piles, okay. So in the case of 2 pile, this is the pile arrangement. This is the pile cap. This is the pile cap, and here this is the pile, this is the pile, or this is the column, okay. So the distance between 2 piles should how much, so we have to follow, that is, I'm just saying here, so you will cop up the things very easy, just zoom it, okay. See the distance between 2 pile, this is the pile and this is also pile, okay, and this is the pile cap and this is the column, okay. So the distance between 2 columns center to center how much, 2.5 times diameter of the pile, okay, you have to keep. This is your pile cap, you are going to provide 2 pile here, so the distance between 2 pile how much, that is 2.5 into diameter of the pile. Suppose this diameter of the pile is, we are taking 400 mm, okay. So now in case this is your pile and you have to provide the 2 pile, and this diameter of the pile is how much, 200 mm, so 400 mm. So we know that in the case of pile, the minimum we can provide is how much, 2.5 into diameter of the pile, the minimum distance between center to center of the pile. So just go for 2.5 into 400, just multiply here, so how much getting 25 into 4, so means 1000 mm distance you have to provide here, okay. So this is the criteria you have to follow. And minimum offset how much you can provide from here, so that is 150 mm from here to here distance. This is the pair, this is the pile cap outer face. So the distance between from here to here, how much? So 150 mm minimum. You can see here also. See, from here to here 150 mm, from here to here 150 mm minimum. You can give the space. Okay, so I hope you got it. So this is the criteria for the pile. Okay, next we'll see that like 3 4 pile, 5 pile, 6 8 9 piles and all. Okay, so in this case this is for the 2 pile. Okay, this is for 4 pile. So in the case of 4 pile, what happen is that this is the diameter, this is the diameter, this is the diameter, and this is the diameter of the pile. Okay, and this is the column. So in this, suppose you have 4 pile, then the shape of the pile cap should be like this. Okay, here, 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 and in between we generally provide the column. Okay, so the distance between these two, the distance between this, how much? 150 mm here, from here to here also 150 mm. Like this here also you have to provide 150 mm, and this distance also 150 mm. So here also 150 mm, this distance 150 mm, this distance also 150 mm, and this distance also 150 mm. Also you have to remember, that the pile edge to the pile edge, the distance between the pile edge to the pile cap edge is minimum 150 mm you have to provide. And the distance between these two, how much? This is 2.5 into diameter of the pile. From here to here 2.5, from here to here also 2.5 diameter of the pile. Okay, you have to remember this thing. So this is for the 4 pile. Okay, we have seen that first one is 2 pile and second one is 4 piles. I hope you got it. That, see here, this is the pile, sorry, pile, 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 and this is column. Okay, so this distance should be how much? So this is 2.5 into diameter of the pile. Okay, so from here to here distance, center to center, how much? So you have to go for the 2.5 into diameter of the pile, same. And from here to here distance 150 mm minimum, and means vertically 150 mm minimum and horizontally 150 mm minimum. You can go for that. You can see here. Okay, because for you only I have created the drawing and all. Okay, for the plan, with plan, that you can understand with figure also. So please, I request you that please share, subscribe and like my channel. Okay, and I am telling you again that because already I am taking many online lectures for the students. Many students, they are learning ETABS and all. So those who are interested, you can directly call me. I have given my number initially and with my email ID. Okay, so you can contact me, that in very cheap price you can learn ETABS full from basic to the advanced level with company life projects from initial stage to the GFC. Okay, with each and you can learn more than G+40, G+50. Okay, we'll start from the bottom and we'll go for G+40, G+50 up to Pro, like that. Okay, so those who are interested, you can contact me directly without any hesitations. Thank you. So here already we seen this thing 4. Now we'll see next. Okay, see here, suppose you have 3 piles. In case suppose you have 3 piles, then what are the reinforcement? This is the reinforcement, horizontal ties to prevent bursting due to tensions. We generally provide this thing. Okay, like that. This is the reinforcement detail. See, like this we can generally provide. Okay, for 3 piles. But what are the arrangement? So arrangement should be like this. Okay, this is the pile cap. The pile cap should be like this. Okay, if you are going to design the pile and pile capacity, according to pile capacity you need only 3 piles. Okay, so in this case what we will do, so you will directly go for the pile cap capacity. We'll see that how much we generally need, and accordingly we generally provide the number of piles, because it totally depend upon the loading condition that is come from the superstructure to the column. Accordingly we'll decide that what should be the how many number of piles we can provide. Either we have provide 2 piles, 4 piles, 3 piles, like that. Okay, so here sometimes you will get 2 piles, sometimes you will get 4 piles, and sometimes you can get 3 piles. So we'll see here 3 piles. Okay, so in the case of 3 piles, this is the pile, this is pile, and this is pile. Okay, so the distance between this also how much? It should be 2.5 into diameter of the pile. Okay, here also the distance should be 2.5 meter diameter of the pile. From here to here also 2.5 meter into diameter of the pile we generally provide. Okay, and minimum offset 150 mm, 150 mm you can see here, 150 mm. Okay, but shape you have to remember. Okay, this is very important, how we can provide the shape in the case of 3 piles if required. So shape should be like this. Okay, just go for like this. Okay, and then trapezoidal like this. Okay, so like that we can generally provide the first pile here, second pile here, third pile here, and in between we generally provide the column. So this is for the 3 piles. Suppose you have 7 piles, then what you will do? So you can see here. Okay, not 7, suppose that this is, I'm sorry, 6 piles. Okay, suppose you have 6 piles you have to provide. So what should be the shape of the pile cap? It is very necessary. I really I'm saying that you will ask to many persons that what will be the shape. Suppose we are going to provide 6 piles and all, so what will be the shape of the pile cap? So mostly they will say like this. Okay, they will go for the rectangular, they will say like this, 3 here provide, just 3 here provide in between column. But this is wrong. Okay, because we have to distribute the load, that column load that is coming from the superstructure, we have to equally distributed for all the piles. But in this case it is not possible. Okay, in the case of 6 piles, in the case of 4 it is okay, we can go for that, because you have to maintain the 2.5 into diameter of the pile also. Okay, so here we can see in the case of 6 piles, this is the shape of the pile cap should be like this. Okay, like this. Okay, and here just provide here and just provide here. The distance between each pile, center to center, should be how much? 2.5 into diameter of the pile for each. Okay, like this, and in between we only provide the column. So I hope you understand that what are the basic criteria to provide the piles arrangement all, because this is very important. This is the initial stage when you are going to design the pile and all. So with the help of AutoCAD you have to create these things, and then after you import this in the safe, and then you start for the design. So you have to be finalize that according to calculation and all that, how many number of piles we generally require according to the load capacity. Then after we go for either we require 2 pile, we require 4 pile, we require 3 pile, or we require 6 piles. Accordingly we will decide for the pile cap shape, and then we'll go for that. Okay, so for today it is enough. Okay, for next lectures we'll continue with next topic. So thank you so much, and in last also I'm just saying that if you like my channel, please share, subscribe, and like. Okay, and other thing is that those who are interested to learn, kindly contact me. Okay, without any hesitations, with cheap price you will learn more and more, I guaranteed you. Okay, thank you so much.